Now let's take a look at example number 4, which asks us, is g of x equal to the absolute value of x differentiable everywhere? Well, we kind of just talked about this, all right? We know that this particular type of function, well, there's a sharp turn in it. So we're going to say that this is definitely a no. There's a sharp turn, which is also referred to as a cusp in a graph. Sharp turns are known as cusps. There's a sharp turn at the vertex, which is at x equals 0, okay? But here's another reason why, all right? We talked briefly about how this can be written as a piecewise function. So this is g of x is equal to positive x when x is greater than 0 and negative x when x is less than 0. Okay, and I can put the equal to on either one of these. It doesn't really matter which one, okay? So then, graphically, we're looking at y equals x over there and y equals negative x on the other side. Well, what is the slope of this line? The slope here is positive 1. And then on this one, the slope is negative 1. So what that tells me is this. I can say that g prime of x is also equal to a piecewise function where it's equal to positive 1 when x is greater than or equal to 0. Actually, I shouldn't have the equal to there, sorry. Just when x is greater than 0. And then negative 1 when x is less than 0. I can't actually equal 0 in this case because that's the spot where I have the vertex down here, and that's where I'm abruptly changing from one to the other. So the derivative is technically undefined at 0, okay? So this is the case where the answer is no. It's not differentiable everywhere because of that sharp turn or cusp in the graph, okay? And it's because of how an absolute value function is piecewise defined that happens.